So let's talk about one of the homework question, which is the second in the second section, problem 23. So the question asks you find the limit as x approaches to 16. What's the limit it's supposed to be like? I just want to clarify for web work problems, students have similar questions, but the numbers are slightly different. So when I have those numbers, it's not necessarily identical to what you would be seeing in your web work problems. Okay, so let's try to solve it. The intuitive idea is try substitution. So I try to substitute 16 here. I end up with 1 over 4 minus 4, which is 1 divided by 0. The second half is 8 divided by 16 minus 16, which is 8 divided by 0. So that's something not really very intuitive. And if you want to, we don't really know what answer should we be getting. So one thing I want to do is just like what we talked about in class today, is there any way for me to simplify this problem such that I can have a concrete conclusion whether the limit does not exist or it exists and what exact that answer is supposed to be. So it's slightly counterintuitive. It's exactly the opposite of what we did in class today. So for this particular set, we talked about when you have square root and a constant, when you try to multiply some quote-unquote conjugate pieces together, you end up with a nice squared behavior. So what you have here actually is root x minus 4 times root x plus 4 if you think about it, right? So for those two pieces multiplied together, it's going to be root x squared, which is x, and then 4 squared, which is 16. So your denominator on the right-hand side is actually going to be relevant to the denominator on the left side, which is root x minus 4 minus 8 times root x minus 4 times root x plus 4. So once I have that, I'm going to say, well, you have different denominators. Why don't you make sure you have same denominator? So now they look identical to each other. So now two problems sharing the same denominator, I can merge them into one expression. The first half have 1 times root x plus 4, namely it's root x plus 4. The second half has minus 8. Well, I can easily simplify it. My numerator becomes root x plus 4 minus 8, which means it becomes, after simplification, root x minus 4. So you look at your problem one more time. You have root x minus 4, root x minus 4 appear both on your numerator and denominator. So I have a beautiful cancellation. So my answer is supposed to be limit x approaches 16. And then I have this cancellation. So I have 1 left on the top. I have root x plus 4 left on the bottom. So I end up with 1 over root 16 plus 4. So 1 over 4 plus 4. So I have 1 over 8 as my final answer. So this is how we can solve this problem. Slightly different from the way we worked in class because I did try to factor this expression, but it's based on what we talked about in class, that when we have root expression and when we try to use this quote-unquote conjugate structure, I can technically factor linear expressions, okay? So hopefully it's going to help you to resolve problem 23.